So, Abby,
Yeah?
at this point we've learned quite a bit about blimps. We understand how they're made and how they're able to float up into the air.
Sure.
But one thing we haven't figured out is how they move through the air once they get up there.
Sure we have. Isn't that what buoyancy's about?
Not really. Buoyancy is the ability for an object to float in air or water. That's how we know how the blimp moves up and down.
Okay, you're right.
But we still need to figure out how they move around once they get up into the air. And that's what makes blimps so special compared to, say, hot air balloons. Hot air balloons just go where the wind takes them. Blimps, though, blimps can be steered. Blimps can go wherever the pilot wants them to.
Well, it's obviously because of these propellers right here.
Well, but there's probably more to it than that.
What are you thinking?
I say we talk to the person who actually flies the blimp. I think we need to talk to a pilot.
Now you're talking.
Do you want to set something up?
Yeah, no problem. I just lined up an interview with Dr. Jim Maloney. He's the head pilot at the Spirit of Goodyear. He said that he'd be happy to... Trista, are you okay?
Yeah, of course I'm okay.
What are you doing?
I'm doing an experiment. I found this balloon down the hall. I think it's a leftover from the rally a couple days ago.
Doesn't look too, buoyant.
I know. I think some of the helium leaked out, but I wanted to show you something.
Let me guess. You're trying to come up with a question to our interview.
Right. Check this out. When I take the balloon and push it forward like this, it starts off quickly but slows to a stop almost immediately.
Right.
But when I take the paper airplane and throw it like this, it goes further. I wonder why that is.
The paper airplane cuts through the air easily, and the balloon doesn't. I bet it has something to do with its shape.
That was my guess too, but why does it make such a difference?
I don't know. But you got a good point.
I'll jot that down on our list of questions.
Yeah, but we really should get going. Dr. Maloney said that we could interview him anytime today.
Sure, let's go.
We now know how blimps are able to float into the air, but how are they propelled once they're airborne? What forces help or hinder their ability to move through the air? That's what we hope to learn here today. We're here at Wingfoot Lake Airship Base in Southfields, Ohio.
So, Captain Maloney, how does the blimp's shape help it fly?
Well, it's an aerodynamic shape like a lifting body, and it actually generates lift like a wing or a lifting body, you know, like the space shuttle. It generates lift as it comes back into the Earth's atmosphere. We're flying around in the Earth's atmosphere, and the shape generates lift. If you point the nose up a little bit, it generates lift. If you point the nose down, it generates a negative lift.
So how does it generate the lift?
Well, it's actually, you've got lower pressure on top of the bag as you increase the angle of attack, and a higher pressure on underneath, and it generates lift from that.
Does friction play a part in how the blimp flies?
Yes, it does, because of everything that's attached to the airship generates drag or friction through the air molecules, and that actually slows the airship down as we're flying through the air. One thing that happens to the airship is as we put those night signs on the airship, each side slows the airship down 3 miles an hour, and that's friction, or in aerodynamic terms, drag.
So, how does the blimp take off, land, and fly?
Well, what we'll end up doing is the ground crew will move the airship out onto the field, and then when the pilot's ready to take off and everything, we'll increase the thrust on the engines, and we'll start moving through the air, and the airship starts flying just from the dynamic lift. But there are times when the crew releases the airship, we have enough static lift that the airship will just float into the air. And then as it floats into the air and everything, we rev up the engines and start pushing it through the air faster than just rising straight up.
So what are the forces in play to get balanced flight?
Well, what you have is you have some static and dynamic lift on the airship. And so, and as we fly through the air and everything, everything that's on the outside of the airship creates friction through the air and everything, and that's called drag in aeronautical terms. And so what we have to do is we have to push enough horsepower through the engines to push the aircraft through the air as fast as we want it to go. If we want to go faster, we have to increase the throttles and increase the horsepower that we're generating with the engines.
So what would happen if you turned off the engines?
Well, most of the time the airship just floats like a balloon, and we would just drift in the winds like a free balloon. But I talked about the static and dynamic lift. Well, once you start floating in the air and everything, you don't have any dynamic lift. The airship is just floating through the air by itself and moving the same speed as the air molecules are moving through the air.
So what do you mean by ballast?
Well, what we do is we put 25-pound shot bags on the airship, and when we put passengers on, what we do is we take off those 25-pound shot bags to compensate for their weight. So when we take off very close to equilibrium. Usually what we'll do is we'll take off just a little bit heavier than that, and that's the amount of fuel that we'll burn in the flight. If the flight's just a half an hour, we'll probably take off 50 pounds heavier, because we'll burn approximately 50 pounds worth of fuel during the flight.
Wow.
When we come back, we're what's called equilibrium, and the ship doesn't want to go up or doesn't want to go down. It just floats in the air, and we'll just fly it in and land it to the crew.
The blimp is aerodynamic. Its shape helps it move through the air more easily and efficiently.
When you use the shape of the blimp to get it into the air, that's called dynamic lift.
Then there's static lift, which is when the helium inside of the blimp is used to lift the blimp into the air.
As the blimp goes through the air, everything on the outside surface creates friction, which causes resistance to the blimp's flight.
These concepts of motion and forces dictate the design of blimps.
There are two shapes used in lighter-than-aircraft, a sphere and a cylinder. The hot air balloon is a sphere that is open at the bottom so a flame can be used to heat the air inside. The round shape allows the balloon to slip through the air as it goes up, while its sides act like a sail on a boat. It's broad enough that a breeze pushing against its side will cause it to travel in the same direction as the wind. In fact, if you go up in a hot air balloon, it feels like there isn't any breeze at all, because you're traveling at the same speed as the wind that's pushing you along. However, when you want to use an engine to propel a lighter-than-aircraft forward, the sail effect doesn't help. To move against the wind, designers started making the balloons long and cylindrical, or cigar-shaped. This shape allowed the airship to slip through the air much more efficiently. Gradually, the shape has widened to take advantage of aerodynamic lift. The design of today's blimp is wide enough that the upper and lower surfaces ride on the air, something like a water ski riding on the surface of the water. As the blimp moves forward, the pilot points the nose up or down, causing the wind to strike the top or bottom surface of the blimp, pushing it higher or lower.